Hello physical science students, welcome to an additional video that we've had to add on to the electrical energy section because in their wisdom they've decided to add something to the syllabus. And so we're just going to cover this little variation in this little video. And it's all to do with circuit analysis. Now by circuit analysis we're meaning looking at a circuit which has a number of resistors in it and then working out the properties of that circuit. Now in the world of electronics, the circuits we're going to look at are very, very simple, but they're a starting point to learning about electronics. And so we're going to do both series and parallel circuits, and I'm going to quickly go through what's different about them and then a couple of examples. So let's start off with analysing a circuit that has multiple resistors, and it's going to be a series circuit, and we'll do the parallel circuit in a second. Now in physical science, for us, the maximum number of resistors we can have in questions will be 3. And if you look at other textbooks and for other states and places, they have more than 3 sometimes. But we're going to limit ourselves to 3. Now all the things that we learned about voltage, current and resistance in circuits, series and parallel, all apply to these circuits as well. So we'll quickly go through and recap those as well. So something like, here is an example of a series circuit with 2 resistors. This is an example of 3 resistors, and we should be able to familiarize ourselves with the symbols that we have here. Now what do we know about these circuits? Well, first off, the supplied voltage, so the PDF or the voltage supplied by the battery, it's shared amongst the resistors, and so each resistor will have its own voltage across it, which we could measure with a voltmeter like this, and these voltages V1 and V2 would add up to the supplied voltage. So that's a little bit different from parallel circuits, so you've got to be on the ball. You've got to know which sort of circuit you're in and what sort of things relating to voltage and current can you use. The other thing is that the current in a series circuit is constant around the whole circuit. It doesn't have a choice, it doesn't split up, and so whatever current you have at A here, for example, you have at B. So this current goes through all the resistors, and that contrasts with parallel circuits, so you've got to be on the ball. Now the total resistance is the sum of the individual resistances, and we have this formula on your information sheet. So the total resistance of the circuit is R1 plus R2 plus R3 in ohms, of course. Alright, now what about parallel circuits? A little bit different. Here's another example. Now we can have a maximum of 2 resistors in a parallel circuit, so we simplify it down a little bit, and so here we have our 2 parallel resistors. And what do we know from our understanding of parallel circuits? Well, first off, the current is shared amongst the resistors. The current is supplied by the battery here, comes around, comes to a intersection in the circuit, and the current's got a split. Alright, but then when it recombines over here in the circuit, it is back to its original value. And so we can say that the total current in this circuit is equal to the current going through resistor 1 plus the current going through resistor 2. So if we can work out those two, we can work out the total current in the circuit. Now the same voltage exists across each resistor. So if this was a 9-volt battery, for example, we would measure 9 volts across this resistor and 9 volts across this resistor, and that's different from the series circuit. Now the total resistance is also different from a series circuit. The total resistance is less than any of the resistances and is calculated by the equation. So we are given this equation, which is actually a simplification of another equation that is used elsewhere in other courses, where you can have more than 2 resistors, but we've simplified it here, and this is on your information sheet, so you don't have to memorize it, you just have to remember how to use it. And so the total resistance in the circuit is R1 times by R2 divided by R1 plus R2. Now let's have a look at what that means. Okay, I forgot to say, remember when we were talking about voltage, the voltage across V1 plus equals the voltage across V2. Yeah, I should have clicked then. Now here's a simplifying. So we've taken the resistors out of circuit because we've got to be certain that we can actually work out the total resistance of the circuit. So we're ignoring the rest of the circuit and we're just saying, well, here are three resistors in parallel. What is the total resistance that these guys represent? And we have a 4 ohm, a 10 ohm and a 15 ohm. So we know when they're in series we add up the resistances. So it becomes a simple case of just adding up 4, 10 and 15, and so the total resistance of this, if this was the only resistance in the circuit, would be 29 ohms. And theoretically we could replace this combination of resistors with one resistor that has a resistance of 29 ohms. Now let's look at this resistor here where we have our two resistors in parallel, and we can work out the effective total resistance of these two resistors. And we use our formula that we have, simply put the numbers in. So this time it's 4 times 16 divided by 4 plus 16, and that would give us a total resistance of 3.2 ohms. And remember what we said, the combined resistance is less than the individual resistors. Now we could replace these two resistors with, of course, a resistor of 3.2 ohms. Now let's put this into a circuit and do two quick examples. What do we have? We have a series circuit with two resistors. We have 100 volts being provided. At this point here we have 1 amp, and we know that this resistor is 60 ohms. So we're missing some things. We don't know the resistance here. We don't know the voltage across these two resistors. Well, we do, but we're going to work that out. So let's work our way through it. And these are pretty typical questions that you would get. And they could happen in any order, and you'd have to work things out depending on how you go. So first off, what is the current at point B here? Well, it's a series circuit, and so since the total current is equal to the current through A, which is equal to the current through B, which is equal to the current through C, we get 1 amp. What is the voltage drop across R2? And so we want to imagine we put a voltmeter across here. What is the voltage? And now we know the current and we know the resistance, so we can use V equals IR, and we put our numbers in and we get 60 volts. The voltage drop across R1. Now if we know that this is providing 100 volts and this is 60 volts, and it's a series circuit, so we know that the voltages must add up to give you the total voltage. We can now work out the voltage on R1, which is going to be 40 volts. Alright, the value of the resistance in R1. Now we have the current and the voltage, so again we can use our equation V equals IR. In this case we want to solve for R, so we rearrange it, put our numbers in, and we get 40 ohms. Let's do another example. In this case it's a parallel. We've got a bit of information which is on the graph here, or on the figure here. We've got 9 volts, we've got 1.35 amps, and we've got 10 ohms, but we're missing other information and we're going to have to work it out. So let's just go through them. What's the voltage drop across R1 and R2? Now remember, this is a parallel circuit and it's 9 volts, so for parallel all the resistors get the same voltage, therefore they're both 9 volts. Don't confuse that with series. I2, the current flowing through the second resistor, so we want the current here. Now it's not going to be 1.35 amps, it's going to be something less than that. We have to figure it out. So we know V equals IR, we're working out I. We know two things about this resistor. We know the voltage and the resistance, so we put that in and we get 0.9 amps going down this branch. What's the current flowing through R1? Well, we just worked out the current here, and this is the total current, so we can say that the total current is equal to I1 plus I2, put our numbers in, and we work it out to be 0.45 amps going down through this resistor. Now what's the resistance of R1? We know the voltage, we know the current, and so we can use V equals IR, and we get 20 ohms. See how it all falls into place? If we know enough about things, we can work out other things within the circuit. That's why it's called circuit analysis. What's the effective resistance of the circuit? Now we've got 10 ohms here and 20 ohms here. We can't just add them together because it is a parallel circuit. We have to use our formula, and we put our numbers in, and we get 6.7 ohms. So we could replace these two resistors with a 6.7 ohm resistor, and it would have no effect whatsoever on the rest of the circuit. And that's it. Now in class we'll have a couple of examples of these for you to do, and so hopefully that will be clear. Cheerio!